Uh, good morning, everybody. Welcome to our seventh technical workshop organized by the ANH. We have now, today we have the talk titled New Findings on Petroleum Exploration in the Paleozoic of the Llanos Basin, organized and given by the Colombian Geological Survey. Always the news that we always pass on weekly basis. I mean, don't forget that we have financial support for buying data in frontier areas for research groups and companies. Evaluation results have to be presented in this space to the industry in the ANH technical workshops. Application must be submitted to Pedro Rangel in the Colombian Geological Survey. And the second one, last year, a student and professional graduated recently who find thesis program and or projects to develop plus financial support. Third quarter 2022, I think that the opening is in May. Please pay attention to that. Please contact Diana Rua, MinCiencias. So this is our last, I'm sorry, this is our talk on May 18th. And I would like to maybe call the attention on our next talk on March 25th, and it's going to be given by the ANH. Couple of interesting areas, one in the lower MAC and another one in the Llanos. One in the lower MAC in the Arjona area, and the one in the Llanos in the heavy oil area of the country. And don't forget that we have scheduled already the talks on gas, and we have on April 8th our next talk organized by UPTC University, Value Chain, Legal Framework, and Geopolitics of the Natural Gas Business in Colombia. So every month we are going to have those gas talks, so don't miss any of them. Just to recall you that we have so far promoted 14 areas for nomination, and those are in this map, in the middle MAC, and in the Catatumbo, and in the Llanos. In this slide, I have just here the address. If you want to access the recording of all our presentations, 6 so far, today we'll have the 7th one. And below that here, you have the access to our web page. Okay? If you want more details, don't hesitate to contact us or Daniel Rodriguez for the address for this specific presentation and recordings. We have today we have the pleasure to have 5 great speakers with us. We have all of them working for the Colombian Geological Survey. We have Marcela Mallorca, geologist from the National University of Colombia with 20 years of experience related to hydrocarbon exploration in Colombia, geological mapping, stratigraphic analysis, sedimentological studies, geochemical modeling, and prospect assessment. We have also Fanny Villamizar, Master Science Geologist and specialist in GIS, over 15 years of experience in projects of integration of subsurface geological and geophysical information. We have Alexander Piragua, geologist at the National University of Bogota, Master Science of the Royal Holloway, London, UK, with experience in sedimentology and stratigraphy, acquired work in the consulting sector in Colombia. Gonzalo Carrillo, senior geologist from the National University with more than 30 years of experience ranging from sedimentology to reservoir modeling, both for regional exploration and field development projects. Rounded expertise as geomodeler for plastic reservoirs and volumetric studies. Also, experience in basin-wide sequence stratigraphy, paleogeography studies, and play fairway analysis. And finally, we have the leader of the group, Carlos Guerrero, BSc Geology of the National University of Colombia, PhD in Geophysics from the University of Leeds in UK, England, and MBA from the Thunderbird School. More than 30 years in the oil and gas industry, over 20 years of management roles for exploration and products projects. Okay, welcome the Colombian Geological Survey, and thank you everybody for joining us today.
Hello everyone, this is part of the team we are going to present you this talk, and thank you for your invitation, ANH. Okay, so today we're going to talk about the Paleozoic and the new findings we have had especially in the Llanos Basin. Llanos Basin is one of the largest and most prolific basin in Colombia. Cumulative discovery reserves are estimated about 4,500 million barrels in the foothills and more than 3,000 million barrels in the foreland. The well-known petroleum system put the source rocks in the upper Cretaceous, Cacheta Formation, and the reservoir rocks in Cretaceous, Une Formation, Paleocene, Barco Formation, and Oligocene with Carbonera. Tertiary source rocks like Los Cuervos and Carbonera are also mature in the basin, but the oil generated is much lower in comparison with the Cacheta. Although in the past, explorationists have proposed a Paleozoic petroleum system, until today no evidence has been given to support this theory. This is an effort of the ANH and Servicio Geológico Colombiano to add information to continue the exploration activity in the Paleozoic. Colombia started exploration and production activities, particularly in the massive exploration of crude in 1918 near Barranca Bermeja, where today is placed La Cida Infantas field. Since then, the oil and gas industry has been interested in understanding the Tertiary and Cretaceous, and the Paleozoic has been left aside without any interest. Well, not more interest than to know where the drill touches the Paleozoic sediments to give the order to stop drilling and to do the rock hole. That is why most of the wells in the basin just drill and logged few feet within the Paleozoic. That has been called economic basement. There are also some situations that had diminished the interest of the oil and gas industry in the Paleozoic. The first finding were in the Tertiary. The Tertiary is not challenging as it could be the Paleozoic. The reservoirs in the Tertiary are better understanding to have and have good characteristics when compared with the possible Paleozoic reservoirs. The integrity of the Tertiary traps is better than the Paleozoic traps because the Paleozoic is much more structured. The generation, migration, and charges is more challenging in the Paleozoic. For these previous reasons, in Colombia, the Paleozoic is still unknown. Whereas in North Peru, Ecuador, Colombia, and Venezuela, the oil and gas industry is focused on the Cretaceous and Tertiary targets. In South Peru, Bolivia, and Argentina, there is production from Paleozoic. In Argentina, the Paleozoic basin, Formación Los Monos, produces from the Silurian and Upper Devonian. This formation is also a source rock in Bolivia. It has TOCs between 0.5 to 1.5% and a maximum reflectance between 1.8 to 2.2. Kerogen type 1 to 3 and 3 to 4. Its thickness varies from 500 to 1,000 meters. On the other hand, in North America, there are many sources like rocks from Paleozoic. Lower Carboniferous in Barnett and Fayetteville, Middle Devonian in Marcellus and Utica Sea, and Upper Devonian, Antrim, New Albany, Ohio Shale, and Woodford. According to Magoon and Dow, to identify a petroleum system, the explorationist must find some petroleum. Any quantity of petroleum, no matter how small, is a proof of a petroleum system. An oil or gas sieve, a show of oil or gas in a well, or an oil or gas accumulation demonstrate the presence of a petroleum system. The main purpose of this work is to find whether or not there is a petroleum system in the Paleozoic. First thing is to investigate if Llanos Basin is having a source rock with enough quality, meaning good total organic content, understand the type of organic matter, find out how mature is that matter. Currently, the project aims to find information about the other elements, meaning seal and reservoir rocks, and the processes of the petroleum system. For this latter, we need to understand the deformation of the basin and if there were good conditions for the generation, migration, and accumulation. However, if the basin has good Paleozoic source rocks with favorable story for generation, even if the other elements of the conventional petroleum system are not good, the basin will have still good potential for unconventionals. Why Paleozoic? According to the evidence collected by independent studies, rich source rocks are concentrated in several stratigraphic intervals in the Phanerozoic eon. That unequal distribution of source rocks is on a global scale and in a given sedimentary basin. Specifically for the Paleozoic, there are anomalies in the Silurian time, in late Devonian, and in early Carboniferous and late Permian. There is an additional fact. About 90% of the world's known oil resources were generated in 34% of the Phanerozoic time. Major Silurian source rocks occur in the Middle East, North America, and in the US. The Silurian source rocks contain mainly kerogen types 1 and 2. Natural gas, however, constitutes a major part of the hydrocarbon generated from these rocks, partly because of their deep burial to gas generation window. The Devonian had similar conditions to Silurian, although the global temperatures and sea levels dropped slightly. Devonian shales and marshes deposited during this time contain kerogen type 1 and 2 and generate huge amounts of oil. These source rocks occur in North America, South America, North Africa, Eastern Europe, and Ural Basin. In Australia, these source rocks contain kerogen type 3 planted that generate natural gas. During late Carboniferous, early Permian, the world entered cold climates with sea level drops globally and glaciation in parts of the Gondwana. During these periods, conifers appeared and were abundant in the tropical supercontinent of Laurentia Baltica, and ferns were dominant in the southern cold supercontinent Gondwana. Therefore, late Paleozoic source rocks are rich in kerogen type 3 and coaly material and have good generated considerable gas accumulated in the Permian Triassic reservoirs. Anadarko Basin, located in Oklahoma, Colorado, Kansas, and Texas, sedimentary column ranges from 600 to 1,200 meters in the deepest part of the basin. It produces from Carbordovician through Permian. Estimated cumulative resource production are more than 125 TCFs of gas and over 5,400 million barrels of oil. At least 6 oil and gas petroleum systems work in this area. Source rocks units in Ordovician, Devonian, and Carboniferous, and the kerogen type is 1, 2, and 3. Permian, located in the West Texas and Southeast New Mexico, has produced for more than 100 years, more than 33,400 million barrels of oil and more than 118 TCFs of gas. In 2016, AIA estimated remnants proven reserves for more than 5,000 million barrels and 20 TCFs of natural gas. With those numbers, it becomes one of the biggest producing basins in the USA and in the world. Arkoma Basin, placed in Oklahoma and Arkansas, is producing from Pennsylvania. MacArthur Basin, with Paleoproterozoic and Mesoproterozoic production, it has conventional and unconventional production of oil and gas. Lena Tunguska, more than 30 fields have been discovered. Located in the Siberia Craton, this super province is having production from the Mesoproterozoic and Paleozoic, with 3 provinces producing from Precambrian to Carboniferous. Oman is producing from Neoproterozoic to Cambrian source rocks, and Tundeni Basin, the petroleum system is in the Precambrian and Silurian. Going closer to the Llanos Basin, in western Venezuela, the main source rocks are in Devonian, are mainly mudstone and limestones. More to the east in Los Andes, the source rocks still Devonian, but little older, they are red mudstones. Further north, the rocks are showing metamorphism and some intrusions. Within the spinograph, the faces are sandstones. In North Africa, Maya and Mizot, the source rocks are mainly Silurian and Devonian from Caledonian to Frangian. Additional to the challenge mentioned before, along the exploration and production history, the Paleozoic has been despised. No interest has been put on acquiring information from it. In the decade of 90s and before that, the Paleozoic was considered as basement. With the time, this expression was changed for economic basement. Most of the wells just drill some meters within the Paleozoic just to make a rack hole in order to have some space for the log tools and other devices. All these behaviors comes from some myths that this project wants to understand and remove if possible. With the information available so far, some of the myths are questionable, but further analysis have to be completed and the lab results have to be ready to include those outcomes in the model. Metamorphisms, for example, certainly in the Eastern Cordillera, we have found some rocks with low metamorphism, mainly of contact and dynamic nature. Probably there is also burial metamorphism because Paleozoic rocks were and are buried to depths of several kilometers and at high temperatures. In this condition, new minerals grow, but the rock does not appear metamorphosed or exhibit low degrees of metamorphism. TOC. In the field, there are some levels with high concentration of fossils. These levels are found within the fine-grained rocks. More results are needed to prove that there is enough organic matter. From previous studies, it has been reported low to medium values of TOC. The results from lab analysis will add valuable information for understanding this issue better. Maturity, with regards to this, the wells, the information have shown values of vitrinite/2. At the north of the basin, there are low values of maturity. Again, more information is needed to understand maturity. Reservoir quality. The great majority of rocks are tight, but there are also quality sandstones. Additionally, in thin sections, dissolution and dolomitization can be identified. It is also expected to have Paleozoic rocks with important degrees of fracturing. In the previous phases of this project, the activities have been divided in four: acquisition of surface information, seismic interpretation, core and cutting analysis, and lab analysis. The surface geology compromises acquisition and stratigraphic information of the Paleozoic outcrops and sample collection. Seismic interpretation covers also well information analysis. Well sample analysis also includes the depiction of the information and sample collection. The lab analysis includes vitrinite, rock-eval, TOC, petrophysics, and XRD. In this final phase, during this year, other disciplines like structural geology, stratigraphic petrophysics, and geochem are part of the team to integrate the information acquired and the lab results. The information here is not exhaustive, and much more information has to be produced. This presentation has the only purpose to deliver some findings. This project is still in construction. This is still in construction, and more information is being produced as we speak, and it is going to be included in this study. Some information presented here can be changed at the end of this project. What have been done? Now we are going to have Marcela and we're going to talk about the surface information acquired.
Good morning, everyone. And I'm going to talk about the studies in subspace of Paleozoic rocks. For this study, we selected 3 areas on the Eastern Cordillera and foothill of Colombia: Rio Bata, Guatiquia, and Ariari area. The foothills of the Cordillera are dominated by troughs towards the foreland, and the Paleozoic units are exposed in the hanging wall of main troughs that are affected by transverse zones, like in the Ariari area and the Guatiquia zone. In this project, we measure about 4,500 meters of stratigraphic sensor, and we mapping around 320 square kilometers. The first area, called Rio Batá, is located approximately 7 kilometers to the northwest of Santa Maria, in the south of the Boyacá department. This section was studied on the Rio Batá and on the way between the towns Guateque and Santa Maria. For this stratigraphic column, we described about 2,400 stratigraphic meters and collected around 1,267 samples, with different objectives like petrography, geochemical analysis, petrophysics, and geochronology. Along this section, we identified 6 units, those from the Devonian and 4 from Carboniferous. And in these units, we identified 3 intervals which are characterized by have a predominance of sandstones, and they are from bottom to top, Devonian 1, Carboniferous 1, and Carboniferous 3. On the other hand, in the same section, there is an important thickness of claystone, siltstone, and moonstone, apparently with a good content of organic matter, especially in the Devonian 2, in this interval. You can see that feature in these pictures. San Isidro. Okay. With the interesting finding in this column are the impregnations of hydrocarbon in some sandy levels of Carboniferous 1, Carboniferous 2, Carboniferous 3. Some of them are homogeneous and continuous, like in these pictures in the upper part. In some of the thin sections that have been made in these units, the presence of bitumen has been reported. This bitumen is filling pore space. You can see that in this part. In the second study at Batá, we have preliminarily interpreted tidal dominate strain depositional environments for Devonian 1 and shallow marine environment for Devonian 2. For the sediments of Carboniferous 1, we have a wave dominate strain environment, while for Carboniferous 2, we have a fluvial environment, lateral bars, and mid-channel bars. For Carboniferous 3, we have a fluid, we have again an strain environment, and finally for Carboniferous 4, we interpreted a barrier lagoon system. The next area is Guateque, which covers around 260 square kilometers and is located in the department of Meta around the towns San Juanito, El Calvario, and Villavicencio. Here we made the description and sampling of 4 stratigraphic columns, Quebrada San Isidro, Quebrada La Zapa, and Quebrada Pipiral y Diamante. With a total stratigraphic thickness of 1,090 meters and around 330 samples. The first column stratigraphic are San Isidro, Quebrada La Zapa, Quebrada El Diamante, y Quebrada Pipilar. La Quebrada San Isidro corresponds to the more northernmost stratigraphic column and is characterized in the lower part by an alternation of sandstones and moonstone that toward the top of the section change to a predominance of sandstones with cross stratification. This unit is in angular unconformity with some sediments from Jurassic or Lower Cretaceous. The next one is the section Quebrada La Zapa. Here we identified three intervals, probably deposited during the Carboniferous. The lower interval corresponds to interbedding of reddish siltstones with muddy sandstone of very fine grain and reddish color. The middle segment is mainly claystone and fossiliferous limestones, and the upper segment is composed by quartz sandstone. In the Quebrada El Diamante, two intervals were identified. The lower one, probably of Devonian age, is composed of gray claystone, and the upper one, post-Devonian, has greenish gray claystone and reddish clay sandstone. The last section in this area is Quebrada Pipiral, in which there is an important sequences of 120 meters of dark gray to black claystone, probably of Devonian age, which must be studied in detail to evaluate at the source rock potential. In this slide, I want to show you some of the already mentioned characteristics of the columns study in this area. For example, the angular unconformity in the Quebrada San Isidro between Devonian and Jurassic age sediments. In the right side upper part, we can see some of the fossils found in the Quebrada La Zapa, some crinoids and some part of corals. In the lower part of this slide, we have outcrops in the Quebrada Pipiral and El Diamante of dark gray claystones with organic matter. Regarding the geological mapping, we had an advance since what has been mapped as a single unit in previous works. In this study could be divided into units of Paleozoic age. One of them was called Precapas Rojas de Guatiquía, and the other one is Capas Rojas de Guatiquía. The first one is from the Devonian, and the second one is from Carboniferous. Additionally, we mapped a unit composed of conglomerates from Mesozoic age, perhaps Jurassic or Lower Cretaceous. In addition, we identify and refine the trace of some faults, such as El Calvario and San Juanito faults, and other structures like the Montfort anticline. These elements increase the knowledge about the tectosedimentary evolution for this basin. The last study area is the Ariari zone, located to the southwest of the town El Dorado. In the Meta department, it corresponds to a polygon of 60 square kilometers in which 4 stratigraphic sections were studied, whose total stratigraphic thickness was 952 meters, and we collected 214 samples for different objects. The stratigraphic columns in this area, Quebrada Caño Loco, Quebrada La Cristalina, Quebrada La Tribuna, y Quebrada Caño Leche, was studied. Quebrada Caño Loco and Quebrada La Cristalina are characterized by siliciclastic sequences of undeterminate Paleozoic age at the moment. To the south of these sections is the Quebrada La Tribuna column, in which 5 intervals were identified. The first interval is known as Calizas del Ariari, is a thick sequences of limestone. The same interval was measured in the Quebrada Caño Leche. Overlying the Calizas del Ariari, we found a transitional sequence between limestone and siliciclastic sediments. The upper part of this section are siliciclastic deposits probably associated with a farm delta environment. In this slide, I want to show you 2 pictures of thin sections in which the presence of organic matter was reported. On the left side is a sample collected in one of the upper segments of the Quebrada La Tribuna, and on the right side, we have a sample of the Ariari limestone in the Caño Leche section. The same way as in the Guatiquí area, in the Ariari zone, a geological mapping was developed that allowed refining the cartography made in previous works. On the left side, we have the cartography that existed before of this work, and on the right side, we can see the geological map made in this study. Within the project area, it was possible to cartographically identify 5 units whose age have not yet been defined in this study. Additionally, within the geological mapping, the outline of the Algeciras Fault was refined and 2 new faults were identified, the Alto Cumoral Fault and the La Playa Fault. To finish, I wish to emphasize the importance of surface geology as a complementary tool for the evaluation and understanding the tectono-sedimentary evolution of basins, especially those that are frontier basins like Paleozoic Basin in Colombia. Thank you. Now, our colleague Fanny Villamizar is going to speak about the subsurface interpretation.
Good morning, I am Fanny Villamizar. I'm going to present the progress of the geophysical and geological interpretation of the Paleozoic project in the last year. It has increased our geological knowledge with a hydrocarbon focus in this basin. What has been done? The Junior Petrotechnical Project interpretation of 50,000 kilometers of reprocessed seismic data interpreted, 406 wells reviewed, 80 wells studied and analyzed by stratigraphic revision and validation, distribution of updated chronostratigraphic sequences, 8 regional seismic sections, 9 stratigraphic correlation, identification of structural domains, maps in time and depth. This is the generalized stratigraphic column. The 7 chronostratigraphic sequences interpreted in this basin are Cambrian, lower to upper, 2, lower Ordovician, 3, middle Ordovician, 4, upper Ordovician, 5, Silurian probably lower, 6, Devonian probably middle, 7, lower Carboniferous, probably Mississippian. With these 7 mapped sequences are for unconformity. The sphere 1 is the lower to middle Ordovician. Second, in the upper Ordovician to Silurian. Fifth one, in the Silurian to Devonian, and last one, in the upper Carboniferous, in which we don't have evidence of a Permian sequences so far in the basin. In addition, approximately 12 palynological zones have been identified by our expert in biostratigraphy, Dr. Hernando Dueñas. This slide shows examples of seismic section in phases 1 and 2. In the north, in the Arauca half-graben, with lower Paleozoic and probably upper Paleozoic sequences. Towards the center, the sequences are more continuous in a stable craton, which allows the deposition of Cambrian, Ordovician, and some Silurian sequences. The south, the position is in the basin between high basement, product of rotated blocks, and contain Cambrian, Ordovician, Silurian, Devonian, and Carboniferous sequences. This map shows 4 seismic sections and 50 wells analyzed last year distributed in the basin. The map of structural domains for the Paleozoic in the basin was created. A domain north called Arauca with faults in a northeast-southwest direction. The domain Casanare and Villada with north-south fault, and the south, the domain of Meta with north-south fault, which has a major and relevant structure in the basin called Viento Fault. The seismic section carried out during phase 3 were performed in the central area. We show a pericratonic basin deepening towards the west, overlapping towards the basement, and where a large magnitude intra-Ordovician inconformity is evident. Structural, stratigraphic, and mixed trap are observed in these sections. This slide shows the lower sequences, Paleozoic sequences, which are the most widely distributed in the basin. The Cambrian is the most extensive sequences and is followed by the lower Ordovician, middle Ordovician, and upper Ordovician. On the other hand, in the sheet are the upper Paleozoic sequences, which are less distributed, such as the Silurian in the center and the south, the Devonian in the south, and Carboniferous and the south, and with some probably in the north. In conclusion, there are enough Paleozoic sequences in the eastern Llanos basin that allows to define elements of the petroleum system. Thank you for your attention. Now follows my partner, Alexander Piragua.
Good morning. I'm going to present the results of the sedimentological study of Paleozoic from Los Llanos Basin, conducted from 2019 up to the present time. 31 wells with Paleozoic intervals have been studied so far in the project. The information and samples have been collected from both cores and ditch samples, cuttings. The results of this study are preliminary, particularly those related to the ages, because we don't have the paleogeological dates yet. Likewise, the sedimentological models constructed in previous phases of the project are being refined at this moment with the integration of further information coming mainly from the laboratory analysis, petrography, XRD, geochemistry, etc. The map shows the location of 31 wells in the Llanos Basin. The yellow color represents the wells with cores, and the orange one, the wells with ditch samples, cuttings, and the wells with orange and yellow colors, for instance, Negritos 1, correspond to both those containing cores and cuttings. This figure illustrates the stratigraphic position of the Paleozoic intervals drill, blue lines, and core, gray cylinders in the 31 wells. The intervals are contained in lithostratigraphic units whose ages ranging from Cambrian to Carboniferous. But as you can see, the majority of wells have drill and core intervals belonging to the Ordovician sequences. The methodology applied to this study comprises 5 activities: collection of information and sampling, drawing of sedimentological logs, definition of lithostratigraphic units, facies analysis, and interpretation of sedimentary environments. The facies analysis follow the flow chart proposed by Dan Rimpold 2010 for environmental interpretation. This flow chart contains 3 main steps: facies definitions, grouping of facies into facies associations, and environmental interpretation. The main results of these all activities are the sedimentary environments which are being integrated currently along with seismic information, stratigraphy, surface geology, in order to construct the stratigraphic model and the GD maps. These two products are the inputs for the play fairway analysis that will be conducted probably in a future phase of the project. As mentioned before, 31 wells were studied between 2019 and last year. 11,854 feet of stratigraphic column were measured during this period, and 1,557 samples were collected in total. We've received some laboratory results until now, 46 results of petrography, 77 of XRD, their preliminary results on the revision now, 139 of organic geochemistry, like the previous one, preliminary results on the revision now, and 51 of petrophysics. This is an example of how laboratory results are being integrated into the sedimentological analysis. In this well, Cantaca 1, one core of about 100 feet long was extracted from a lithostratigraphic unit composed predominantly of sandstones. The unit contains three lithological packages, segments A, B, and C. The petrography carried out in this well allowed to refine the testable information of the rocks and confer the quartz composition of the sandstones, and conferred to the open shallow marine environment interpreted in this core. As a result of the sedimentological study comprising the phases analysis and the environmental interpretations, two environments have defined for the Paleozoic intervals study: shallow marine environment and transitional environments. The Paleozoic phase associations of marine origin are interpreted to have deposited in wave-dominated shorelines on bottoms oscillating between upper shore phase and lower offshore shelf very locally. The transitional environments have divided into two categories: restricted environments, estuaries, and open coast deposits. There are two types of estuaries, tide-dominated and wave-dominated estuaries. This interpretation was based on the features of the filling successions and the occurrence of some particular environments such as sandbars, distinctive of tide-dominated estuaries, and estuarine bays, characteristic of wave-dominated estuaries. The open coast deposits correspond to sandy tidal flats. They're interbedded with facious associations of paleosols, which are characterized by the presence of abundant iron oxides and root traces, and interpreted to result from tidal flats propagation. These deposits were subjected to the subaerial exposure and development of soil forming processes and plant colonization. I want to conclude by mentioning three interesting findings. The presence of hydrocarbon shows in Paleozoic sandstones from several wells in the basin. They correspond mainly to irregular stainings patches with low saturations, moderate to high saturations very locally. The record of macrofossils consisting of complete, well-preserved trilobite shells, which sizes range from 0.5 centimeters to 3 centimeters, in dark gray mudstones from CPO 17 Stratigraphico 12 well. And finally, the occurrence of dark gray colored fine facies stratify in continuous and thick intervals in the basin. Our job now is to assess the potential of these intervals as a source rock. Thank you very much. Gonzalo will continue with the stratigraphic model.
Good morning. I'm going to present some integration results generated from the products that have been shown by my partners. The subsurface analysis is support on the seismic interpretation products that have been calibrated with the most complete database. The aim is to investigate the evolution of Paleozoic sedimentary systems in the Llanos Basin. This evolution is being illustrated by a series of maps, such as this one, that correspond to the first Ordovician sequence in the Llanos and is a good example for the lower Paleozoic. These regional depositional models show the current day phases distribution, revealing the possible reservoir and source rock position. The colors on the map identify different sedimentary systems. Red colors represent the Paleozoic, and the purple represents the basement in areas where the sequence is absent due to erosion. Yellow represents littoral facies, and the lighter blue represent the lower shore phase and transitional zones. Offshore marine shale phases are illustrated in darker colors. Those areas indicate the current day position of the rocks with the highest potential as source rock. We have found that the facial distribution are strong controlled by basin structural framework, and the stratigraphical patterns are strongly governed by tectonic activity. In the south, there is a province here. So there is a province showing a series of rotated blocks. The southern province is limited by the El Viento fault from the central province, where a broad, more stable platform is also tilted to the west. In the north, the Arauca graben is characterized by block faulting in horst and gravens with deeper depths of the axis. The map are being generated by integration of well information with the analysis of accumulation geometries, seismic phases, and stratigraphical patterns of wells. The following slides will illustrate some of those controls. Middle division is made up by amalgamated sands. Here, this correlation is located in the central part of the basin. From Santa Maria to Entre Rios to STGU 15 in the east. Is showing the configuration of the basin in the central part, made up by a sequence of early Paleozoic from Cambrian to late Ordovician. Middle Ordovician is made up of amalgamated white sandstones arranged in minor progressional sequence. There is a thickening of the section to the north. In the Arauca graben domain, where the middle of the division contains a series of marine shales, as shown in Santa Maria and in Trinidad wells. The sequence thinning continues to the east below the basal unconformity of the upper Ordovician, this one. Surimena well show thickness reduction of every minor cycle. These sandstones have average porosities of 5 to 8% and are known or shows in a few wells crossing the unit. Cretaceous tertiary unconformity get deeper levels to the east. Arimena and S11A wells does not show the latest Ordovician sequence, while STGU 15 here, the tertiary lies directly on Cambrian. This well provides useful information from Lower Paleozoic. The Lower Paleozoic interval has been dated as Cambrian by Hernando Dueñas. The same author identifies an unconformity during Tremasian or late Cambrian in this position. Red arrows on conformity indicate on-lap direction and established in seismic section. This early Ordovician unconformity is very important event registered basin-wide. This event represents a meaningful change in the positional trends related to a major depocentric migration. The correlation illustrates that lower Paleozoic or Cambrian sequences include more littoral to subaerial sandy facies to the east, and please note that those sequences are thickening to the east. This lamina is just to support the previous one. Is a composite, flattened at double Cambrian here, and it showed that the early Paleozoic start accumulation on the east and is onlapping to south, to northwest. Here, this green horizon is the base of the middle of the vision, and this sequence is onlapping on a different direction to the east. This section is showing how the stratigraphy show evidence of basinal tilting to southwest. This section is located in the west side of the central part of the basin. The upper and the middle sequences of the Ordovician is thickening in this sense. This slide is a composition that illustrates some aspects of the El Viento Fault and the relationship between the two provinces in the southern Llanos. The region on the west of the fault comprises tilted blocks. They define compartments of lower Paleozoic. Here is visible only the eastern one. To the east of the fault is situated the wider central province that also deepening to and thickening to the west against the Viento Fault. This structure, as proposed by previous work, is believed to correspond a major continental junction separating two Proterozoic large igneous provinces of Rio Negro and east of Putumayo west. The great difference in thickness on both sides of the fault and the stratigraphic geometries indicate evident control over the accumulation space exerted by the activity along the fault during lower Paleozoic. Vertical movements involve different subsidence rates and contrasting subsidence on uplifting. On the right side of the image, show 4 sequences that have been constrained by local and distant wells. It is remarkable at the unconformity at the base of middle Ordovician in light blue. It is evident how the parallel low frequency reflectors are truncated against the transparent to chaotic facies in the field of the section. The time during which this incision was created and later filled are concurrent with the climax of the block tilting on the west of the fault. This final slide shows the stratigraphic patterns in the southern province. On the right, it is a close-up of the same section in last slide. And in the left, there is a section from a western compartment. Blue line in the map show the position of this section. The sequences are and tilting climax episodes are the same in both wedges. The Fuente 1A the Fuente 1X is crossing the section at the section, while Melua 1 and Cantaca 1 are projected. Both images show evidence of folding and distortion later times tectonics before the unconformity. Well, this is by now all we get to share with you. I thank you for your attention, and Carlos has some word to close this presentation. Goodbye.
Before I'm going to give you some takeaways, I'd like to talk about the lab analysis. In Riobata, we have done 154 samples analyzed petrographically. Some of the interesting findings are that the western portion of this section exhibits very low metamorphisms, which is normal in most of the outcrops in the Paleozoic in the foothills. There are conglomerates, sandstones, siltstones, and mudstones, and limestones in the section. This section shows some intervals with abundant organic matter, ranging from 3 to 30%. Some intervals are rich in bitumen. Fossil material and live activity was also identified in the sediments. There is secondary porosity due to dissolution and fracturings. With regards to the tectonic environment, it was a passive margin formed of plutonic and high metamorphosed rocks. From the cores and cuttings, 46 samples from 6 wells were analyzed. In Cantaca well, there is organic matter and biogenic activity. In Chaviva 1, fine-grained rocks show biogenic activity. In La Heliera 1 and Rancho Hermoso 2P show mid to high bioturbation. It was found also dolomitization, dissolution, and microfracturing in the thin sections. One of the myths about the Paleozoic is the misconception about the small thickness of the Paleozoic sequences, whereas we has been seen in the seismic are thickness about 7,200 feet at the north and around 1,600 feet close to the El Viento fault. Some findings about the source rocks. There are a lot of fossiferous layers, mostly concentrated in lower division, Carboniferous, Silurian, and Devonian. We have also found black fine sediments, black shales, in outcrops and cores. There is also organic matter in the outcrops and cores. Some cores and outcrops have oil stains with sandstones. And for available information, some wells at the south of the basin show low TOC with high thermal maturity. At the north of the basin, there are thermal maturity low. So in some point at the middle of the basin, we will find the right conditions for the maturity. In the thin section showed in this slide, we have seen some layers of organic matter, which is normal in these in the sections we have prepared for this study. Geometries and traps. Different horizons have been tied and interpreted with the help of palynology. The Permian has been recognized in surface within the Eastern Cordillera, but in the Llanos Basin, it has been not yet identified. Paleozoic is a structure. Reactivation of faults is clear from the interpretation. Although there are some interesting geometries in this basin, more information is needed to define whether or no these are traps. An evolution model has to be ready, and sequences and events have to be more clear to understand the integrity of these traps. About migration, in the analysis of thin sections in Riobata, samples of bitumen was identified. This bitumen is abundant and appears to be interconnected through the pores within the rocks. The oil stains found in Venus 2, Venus 3, and Valdivia 2 are irregular and also locally arranged in layers. In Almagro 1, from samples collected between around 600 feet, was established a TOC of 0.76%, average and thermal maturity between 8 to 8.5 from spores coloration, which means that at this point in the Paleozoic, the organic matter is overmature. A general comment, The most southern part of the basin appear to have a high thermal maturity, which means that possible source rocks are over mature in this part of the basin. This information and the results found so far about the source rock can be good news, because some areas of the Paleozoic could have had the right condition for petroleum and gas generation. About reservoirs and silt, on thin sections has been identified dolomitization fracturing processes that can benefit the porosity of the reservoirs. Other processes as dissolution were observed in thin sections from core samples. In surface, the source rocks show high fracturing. Some of these features are open and in other cases are filled of quartz solution and other minerals. There are neoproterozoic rocks in the basin. Ediacaran deposits have been recognized. Different labs analyses are being performed and to understand these rocks better. Other interesting findings, the feature that separates the Sonsas province and Rio Negro province in the Craton is El Viento Fault. Sonsas is also known as Putumayo province by Moreno and Escalona. This feature is a major fault and can be seen clear in seismic. This fault controls the deposit during Paleozoic. There is a big thickness of Paleozoic deposits at the northeast limit of this fault, probably one of the best places to find fine sediments. I want to finish with this presentation with this picture that shows the unconformity between the Paleozoic and Mesozoic. This landscape is very similar to the one that we can expect at the beginning of the Mesozoic, except for the human being. Well, I'd like to thank you all of you for your attention, and we are ready for answer questions if there is one. Thank you very much.
Okay, thank you, Carlos, from the ANH. And now we got a couple of questions into the chat room. So we got a couple of them related to biostratigraphic stuff. So the first one is asked by Damian Cardenas. How come there are two palynological zones but no biostratigraphic results yet? Did I misunderstood? If not, the preliminary results define two palynological zones for the whole Paleozoic. And a second one by Luis Ignacio Quiroz. Thanks for the presentation. And he's wondering if you have any biostratigraphic data to support a Paleozoic age for the Rio Ariari limestones.
We have some information from pollen material we have found in the area, and Hernando Dueñas have been helping us on putting some edges on this material. With regards to
but now we don't have any palynological data. The age that we know in this section is by relations, geological relation. We collect a good material of rest of fossils in the lower part that resemble echinoids, but the studies are going to do.
Daniel?
Okay, thank you for the answer. We got a last one by Andres Valencia. He said, thanks for the presentation. And he's asking if any of the Silurian shales that have been drilled, any of them have a TOC lab data. And if there are TOC lab data, what are the results?
We have collected a lot of samples, and they are now in the labs. So, and we are receiving some of the results, but they are, as Alex said, they are in quality control right now. And from the recent samples, we have to send them again to the lab, and they are going to last a little longer.
Okay, thank you, Carlos. And this is the end for the amazing presentation, as well as Kurt Bayer said, excellent presentation. And from the ANH, we'd like to thank all of the Paleozoic team from the for the Colombian Geological Service, to its director, Carlos Guerrero, and to the whole team. So remember that next week, the ANH on the 25th of March, will have the seismic program acquired into the Arjona area at the Lower Magdalena Basin. And as well afterwards, we have the area where production returned to the ANH, the Rio Ariari, that was presented today into the terms of the Paleozoic potential. We would like to thank all of the attendees again and see you next week. Thank you, Carlos.
Thank you very much. Bye-bye.